and we will be getting started in a few minutes. All right. Good afternoon and welcome to today's UW-Madison Division of Extension Badger Dairy Insights program. The Badger Dairy Insights series is part of our Farm Ready Research winter programming for agriculture. Today's session is Improving Dairy Farm Efficiency Through Genetics. My name is Amanda Young, and I am the Dairy and Livestock Educator in Dodge County, and I'll be your moderator. We ask that you please mute your microphones during today's presentation, as it will improve audio quality for all our participants. The mute icon should be in the lower right-hand corner of your screen. If you see a line through the microphone graphic, your line is muted. We also encourage your questions during today's session. Please use the chat feature in the bottom center of your screen to type in your questions during the program. So today's program features two sections. Dr. Kent Weigel will share genetic evaluations for feed efficiency in U.S. Holsteins, followed by a panel of extension agricultural agents discussing the analytics of beef on dairy crossbreeding. Our first presenter, Dr. Weigel, is professor and chair of the Department of Animal and Dairy Science at UW-Madison. He holds a research, extension, and teaching appointments and serves as technical consultant for numerous companies and organizations in the dairy genetics industry. His research focuses on genetic selection and genome-guided management programs to improve productivity, health, fertility, and feed efficiency in dairy cattle using tools such as genome-wide whole genome selection, advanced reproductive technologies, crossbreeding, electronic data capture systems, and artificial intelligence algorithms. Dr. Weigel has published approximately 200 peer-reviewed journal articles on various aspects of genetic improvement and management of dairy cattle, and has given lectures to academic, industry, and producer audiences in more than 30 countries. Before we get started, I'd like to take just a moment to recognize the rest of the Extension team contributing to today's program. Matt Lippert, Agriculture Extension Educator in Wood and Clark counties. Ryan Sterry, Agriculture Extension Educator in St. Croix County. Heather Sletcher, Dairy Educator in Marathon County. And Alyssa Seafelt, Dairy Educator in Eau Claire County. On behalf of our team, I'd like to thank you again for joining us today. And with that, we are ready to begin today's presentation.
All right, thanks, Amanda. Sound working well? Okay, great. Well, thanks for joining us today, and we'll cover two topics that are timely, I think, and hopefully interesting as well. The first will be genetic selection for feed efficiency, which is a project that we've been part of for a decade here at UW-Madison. And then we'll talk about dairy on beef strategies, and both are ways to increase efficiency, feed efficiency, economic efficiency on the dairy farm. So genetic evaluations for feed efficiency are new this year, and I'll talk about the background of those and then the research that went behind them. And then also I'll spend the latter part of the time talking about kind of how to interpret and use this new information, because it's new to most dairy producers. So I think it's not surprising to anyone on the call that feed is generally the largest single expense on a dairy farm. And feed efficiency is, improving feed efficiency is beneficial in a lot of different ways. The most obvious, of course, is less feed and the money associated with that. But it's a win-win in terms of the environmental implications as well. So if we reduce feed, we have less manure, less greenhouse gases, better or more efficient land utilization, and so on. And so we can improve feed efficiency in a variety of ways, and I'll talk about those early on, but the majority of this talk, since I'm a dairy cattle geneticist, is going to be about the biological efficiency of feed utilization and how to do this on an individual animal basis. And the tricky part of all of this that I'll keep coming back to is that this requires collecting individual feed intake data for individual animals for a long period of time. So it's really difficult and expensive. If this were an easy problem, someone would have solved it a long time ago. So a lot of the slides here on the nutrition side in particular are from my collaborator at Michigan State, Mike Vandehar. He's a well-known dairy nutritionist there and a terrific scientist and a great guy as well. And he's done a lot of the nutrition side, and we're responsible more for the genetics side. Our team, so I know we'd like to mention later on at UW-Madison for feed efficiency is myself, Heather White on the nutrition side, and then a new faculty member who joined us last fall, Francisco Peña-Garicano, who came to us from the University of Florida. We kind of handle the UW-Madison part of it, but this is a collaboration of multiple universities. So when we think about the feed efficiency broadly, it's really a complex topic, right? We have land and water inputs. We have to think about whether we're producing foods that are consumable by humans or not consumable by humans, because we're dealing with ruminant animals, right? And then you have all sorts of not only feed and land and water inputs, but then you have other inputs, fertilizer, chemicals, and things, and those waste sources. And this gets then really into sort of a life cycle assessment. And that's not what we're going to do today, because that's, I think, well beyond the scope of what we're talking about, and honestly, what I'm capable of doing. But what we're going to focus on is the efficiency of producing milk and beef for human consumption. And, but we don't want to forget about these other aspects of feed efficiency or land utilization efficiency, food security, and so on that are helpful in the dairy industry. And then also, as we'll get into the second part of this conversation today, the efficiency of the beef industry as well. If we break it down just to the dairy farm, we have feed going in, kind of three buckets, right? The lactating cows and the return on that, of course, is milk, the dry cows where the return is calves, and the heifers where the return on it is growth in body tissue. All of these are producing feces, urine, gas, and heat that waste feed once it enters the animal, or use feed energy once it enters the animal for purposes other than what we really want to happen, right? The growth and calves and the milk. But there is also wasted feed before it gets to the animals, and that gets into a lot of the nutritional management strategies that other folks here on the call among the moderators, but also some of our nutritionists and management folks at UW can help with as well. But I do want to emphasize it broadly. Again, this is a slide from Mike Vandehar. When we're looking at whole farm feed efficiency, genetics is not the only solution, and maybe that's obvious to anyone who's not a geneticist. But if we think about energy efficiency or protein efficiency, there are a lot of different things we can do to improve that efficiency, right? So increasing milk production per cow improves both energy and protein efficiency. More longevity, you get more cows producing at a mature level. And again, that's greater efficiency. Reducing age at first calving, because that flips the balance of heifers and lactating cows, or strategies that we'll talk about later on in this call, right? Sex semen coupled with beef semen can also reduce that heifer inventory, keep only the animals you need, which then increases efficiency at both energy and protein utilization. Shorter calving intervals, of course, more cows producing than at the peak level. Nutritional grouping, when implemented, can do a pretty good job of improving feed efficiency. And Victor Cabrera has done a lot of work on that recently. Reduced protein diet, for example, in later lactation cows won't change energy efficiency, changes protein efficiency. But then this feed waste, right? That's a huge chunk. So when I talk about gains through genetics, keep in mind that there are a lot of gains you can make before it gets to the cow that will probably honestly be a lot bigger, and they'll certainly arrive a lot more quickly. One of the things that we have to emphasize, and I'll continue to emphasize throughout this talk, is that for improved production and improved feed efficiency are related. They're not the same thing. And I would say over time, they've become less the same thing. And I'll talk about that on the next couple of slides. but the improvements that we've made in this slide over the last 120 years, from milk recording, antibiotics, genetic evaluations, improvements in nutrition, and those are the different versions of the NRC. They all improve feed efficiency, and in fact have doubled gross feed efficiency over that period of time, and reduced by about 3 or 2.5 fold the carbon footprint of dairy production. And Jude Capper, among others, has done some nice work documenting this. And so we have improved feed efficiency through increased production. We want to continue to do that, but that alone is not enough. And I'll try to explain why on the next couple slides. Okay. So one of the keys to this concept is the multiples of maintenance, probably something you're all familiar with, but the cow requires a certain amount of energy to maintain her body functions in a non-lactating state. When she's not growing or milking, she needs a certain amount of energy for maintenance. And then we can express the feed that is used for creating a product, in this case, milk production, the energy that goes to milk production, in terms of multiples. So 2x maintenance, 3x maintenance, and I'll show a clearer example on the next slide. And as she eats more and produces more, a smaller percentage of what she eats goes to maintenance, and a greater percentage goes to milk production. Okay. And so if you look at this next slide, you have a cow, producing nothing at 1x maintenance, 33, 67, 100, 133 pounds a day. And what you see is you become more efficient in terms of the secreted milk energy divided by the energy she takes in the feed, but it starts to plateau. And that's why we're talking about genetic selection for feed efficiency today, is because of this plateauing. So increasing milk production makes you more efficient, but at a decreasing rate. So as you go from 33 pounds a day to 67, you get a big jump in efficiency, 67 to 100 smaller, and so on. And what's actually even worse is that as cows eat higher and higher levels, rate of passage of the feed increases as well. And so if you then account for that, what we call digestibility discount, it actually flattens out almost completely. So once you get above about 5 times maintenance, you're not really getting more efficient solely by selecting for a higher milk production. Not to say you don't want higher milk production, because it still has value, obviously, but you're not becoming more efficient. Okay. And that's one of the reasons why we're talking about feed efficiency today. The other reason we're talking about feed efficiency today is because of genomics. And so there's a lot of information on this slide, but basically what it does is document, at least the best of my ability, the cost of selecting for improved feed efficiency before and after genomics. And genomic selection has been with us now for about 12 years, and really heavily implemented a little more recently than that. But before that, we were in a progeny testing situation. And so every time we wanted to measure a trait like feed efficiency, we would have to measure it on all the daughters, or at least a reasonable number, say 100 daughters of each new bull every year. And every year there would be maybe 1,500 new bulls introduced in the US. So you're measuring 150,000 cows per year for, let's say, 6 weeks in mid-lactation. You're measuring the feed efficiency of every daughter. You couldn't do that if you wanted to, because nobody has the facilities or labor to do that. If you could do it, it would cost you about $75 million a year, or about $50,000 per bull, just for that one PTA, or the estimated breeding value for feed efficiency. After genomics, and I'll talk a little more detail about this in another slide, but we really are talking about developing a reference population. So we need to measure a bunch of cows, genomic test those cows. I say 25,000 here. It's a dream. We're not anywhere near that yet, but we're trying. And then you can go test new bulls every year, but you don't have to do any additional measurement. You just compare their genomic test data with those of cows that you measured previously. So you invest a bunch of money up front. I say here 13 million. And then the annual cost of maintaining or updating that population is relatively small. And the cost is 150 times cheaper than it would have been before genomics, something like that, right? So now we can do things we couldn't do before. And there was a lot of good research done, especially in Europe, on feed efficiency in the 1980s and 1990s, and they just quit because there was no way to implement it. And it has moved ahead more so in some of the growing animals, pigs, especially chickens, to a lesser extent beef cattle, because it's easier to measure in those species, but it's still not cheap by any stretch. So genomic selection, as I've talked about before, if you've seen me talk about it, I always kind of show this slide to remind people of what we're doing. There are 4 steps. Build a reference population is the first step. Do some math to estimate the marker effects. Go test a bunch of new calves, and then off you go, and you can make some decisions. But the big heavy lift is this first part. And for traits like milk yield or type classification score, the reference population is already there because we have databases of millions of animals that have been measured over many decades. But for a new trait like feed efficiency, you have to start from scratch, and it's really hard and it's really expensive. Okay. So we got a grant now in 2011. Lou Armentano and I were the UW folks on that. Lou has since retired, and Heather has taken his place. It was called Genomic Selection and Herd Management to Improve Feed Efficiency in Dairy Cattle, and there was a similar effort in pigs and in beef cattle. We got the dairy one with Michigan State, and Iowa State and Florida were kind of the main collaborators. There were a couple others in that first time around. And then subsequently, we got another grant from the Council on Dairy Cattle Breeding and Foundation for Food and Ag Research to keep building this reference population. And the key players there are listed at the bottom. USDA is part of this as well. And of course, the Council on Dairy Cattle Breeding is where genetic evaluations for U.S. dairy cattle are computed. And so we're trying to measure thousands of animals and get feed efficiency data, genomic data, and then extend that information to the national population so that anybody else can get a breeding value, even though we don't have feed efficiency data for that farm or for that particular bull's daughters, if it's a bull. Okay. Back to what we're trying to accomplish, we start with gross energy of the feed. We lose some as feces, gas, urine, heat right away, just the process of digesting and getting that feed to where it goes, which gives us the net energy that you use to maintain the body, create milk, add body tissue or growth. And what we really want to do, though, in selection is not get maintenance costs either. We'd like to reduce the maintenance costs. So we'd like to reduce the energy lost up front. We'd like to reduce the energy we expend on maintenance and really maximize what goes to milk and body tissue. Okay, pretty straightforward. Another way to look at this or this question of do I want efficiency or milk production? These are just data from our study. But the point here is that we want both, right? We don't want cows that are producing 30 pounds a day or 60 pounds a day, but eating very little. And that's one of the sort of fears people say, oh, well, you want to get cows that eat less, and so they eat less and they produce less, and then you guys call them efficient. Not really, no. We want high producing cows that are efficient. So really no interest in the lower producing cows, no matter how efficient they are, within reason, right? And at the higher end, we want to get high production and high efficiency both to maximize that captured energy in milk. So what we did in this study, we've been doing this now for nearly a decade, going on that, is we need a 6-week period. We looked at different lengths of time, and we chose 6 weeks as the recording period. Now there might be another week of adaptation ahead of that if we're using electronic feed intake gates or something where the cow has to learn the system, but we want to have a minimum of 6 weeks of data. We do it in mid-lactation for a couple of reasons. One is that the majority of milk happens at that time, right? Peak is between 50 and 200, and so a large portion of the milk and the income generated and feed consumed is during that mid-lactation, but also that's the most stable time. If you do this at around calving time, you've got cows in negative energy balance, they're losing weight, they have more health problems, and you just have a lot of noise happening. And if you do it late lactation, you have the effects of the growing fetus, you have a cow at lower level of production. So we really want to capture that mid period, 50 to 200, when the cows aren't really gaining or losing much body weight or gaining or losing much body condition during that time period. Of course, we measure those things, but we'd like them to be as stable as possible so that we can get the best possible comparison of how much feed was consumed for how much milk was produced, or milk energy, because we do standardize for fat and protein content. There's a lot that has to go into data checking and that sort of thing. I'm not going to bore you with all of that, but it's a lot of work. And then we get to this thing called residual feed intake, and I'll talk more about that in another slide or two. But it's the excess feed beyond what that cow needs for milk maintenance and growth, body tissue gain or loss. But we do it within research station, within experiment, within diet. So we've got cows from Florida, cows from Wisconsin in this, and we need to make sure that we're being fair and comparing cows to their herd mates in terms of heat stress or cold stress. We have cows that are on nutrition experiments or other kind of experiments. We want to make sure that we're fairly comparing them to other cows that are being treated and fed exactly the same way. And part of the reason they're on experiments is because geneticists can't just take over all of the feed measurement equipment on every university farm, for 10 or 20 years, but also because we want to look at what are those differences in nutrition and how they interact with genetics in making this selection for genetic selection for feed efficiency possible. And then the data that we generate are passed on to the Council on Dairy Cattle Breeding for use in genomic predictions. So residual feed intake looks like this math equation on this slide. So we take the observed dry matter intake. We have a contemporary group piece of that. So that's all animals at the same site, at the same time, fed the same diet. We adjust for that. We adjust for the milk energy that she secretes, the metabolic body weight, because maintenance requirements are proportional to body weight to the 0.75 power, which is called metabolic body weight, and then body weight change. The body weight change piece is pretty small, but it's worth measuring. Over a 6-week period, you don't get much change in body weight. And actually, the body weight parts are as difficult as anything in this equation. What we typically do is measure 3 times at the beginning, and 3 consecutive days at the beginning, 3 consecutive days at the end, to try to minimize some of that day-to-day variation. And the leftover part of this equation is residual feed intake. So how much did you eat minus what the cow standing next to you ate, who produced the same amount of milk, were the same size, and were gaining or losing the same amount of body tissue. And if you look at the line, then the line would be the expected intake, and the cows above the line would be considered inefficient, eating more than they need. The cows below the line would be efficient. They're eating less than they need. And of course, this is really, it's really easy, but it's relatively easy in broilers, in pigs, in beef cattle, in a feedlot, because all you have to do is measure gain to feed or feed to gain, the ratio, and select those animals. With dairy cattle, the cows are doing multiple things, some of them not listed here, like getting pregnant, maintaining a pregnancy, staying healthy, returning for next lactation. So we have to be really careful about not selecting for skinny cows that are going to have health problems. Okay. Lots of numbers here on this slide. I'll just try to point out a few of those. Okay. Milk energy and metabolic body weight. So how much milk does the cow produce versus how big is she? At the top, you see a correlation of 0.06, which means big cows give a little bit more milk, not very much more, a little bit more. If you go over one spot, 0.66, they eat a lot more feed. If they're producing a lot, but they also, the 0.45, they eat a lot more if they're bigger for maintenance. And so when you then look at efficiency, the bigger cows are less efficient. There's a minus 0.28 correlation between body size and efficiency. Of course, a large positive correlation above it there for body size, for milk yield and efficiency. In the end, the cows are no more profitable with larger body size. They produce a little more milk, they eat a lot more feed, generally are a little less efficient. Okay. And the point being, and this is probably a clear demonstration of it. This is data from our study. You've got efficiency here, captured energy as milk and body tissue divided by what they ate, relation to body size. And you see in the red, the first lactation cows, in the black, the older cows, not much relationship. It's slightly negative. So as the cows are getting bigger, they're getting a little bit less efficient. Okay. But you can have large cows that are efficient. You can have small cows that are efficient. We're not, saying it has to be a certain way. But if that cow is bigger, she needs to make up for it with higher milk production. And some of them don't do that. Okay. One of the things we found in this research, kind of as a byproduct that really has nothing to do with genetics, is the NRC, the National Research Council, develops the nutritional requirements of dairy cattle every 20 years or 15, 20 years. They update these. And the process is sort of a bunch of nutritionists, well-known nutritionists. Mike Vandar was part of this group, who's in our project. Lou Armentano had been part of this group in the past as well. They sit around, review all, well, they don't sit around, they actually work. And they review the literature that's been published since the last NRC recommendations have come out on nutrient needs in dairy cattle, energy, protein, all of those sorts of things. And one of the things, so at the time that this was done in 2001, the coefficient, we have 0.08 coefficient on maintenance costs, the energy required for maintenance. The more recent research is showing that's underestimated. And you see a couple other studies in 2000, 2015, our data in 2015 from Templeman, depended on the research farm. But the bigger cows actually ate a lot more for maintenance than we thought, about 30% more actually than we thought to maintain their body size. Why does that matter? We're changing the cow over time through genetic selection. We're changing the way we manage the cows. We're changing the diets. And so we have to keep updating this research. And you'd say, well, 2001 wasn't that long ago. Well, but the data that went into that NRC 2001 was from experiments in the 1980s and 1990s. So some of that data in those experiments that were summarized to make that recommendation in 2001, they were already 10 or 15 years old, and now they're 30, 35 years old. And so a lot of time has passed. The new NRC, what will it be called, 2021? I'm not sure. Will have a coefficient of 0.11, I believe. And so the cost of maintaining larger cows will be considered in the nutritional requirements, and the penalty for body size will be much bigger than it was. Okay. Biologically, what is residual feed intake? It's the leftover right after we account for the known energy sinks of growth, maintenance, and milk production. So what's left? How efficiently the animal builds and breaks down body tissue. That's a big chunk of it. This is in beef cattle, these data. We don't have a lot of data yet in dairy cattle. There have been a couple publications on this. We have some parts we don't know of. There's differences in digestibility, feeding patterns, body composition, short and thick versus tall and thin, activity, heat. We're looking at all of these sorts of things to try to identify more sources of variation in residual feed intake in our current population. In other species, people have done selection experiments with pigs, with chickens, with mice. Generally, it results in leaner body composition, but not necessarily so. Mice and chickens got fatter. There's always a decrease in protein turnover, less sort of breaking down and building up body tissue. Mitochondrial function may change. Digestibility tends to improve. Activity tends to go down. That's the other big one, right? So the animals don't do as much, and they aren't burning as much energy for moving around, okay? So back to dairy cattle and the Council on Dairy Cattle Breeding. And what we're looking at here is how to publish the results for RFI, and again, in case I forget to mention it later, RFI on an energy basis. We did not look at protein efficiency in this study, and we have some data on it, and certainly we'll do the research, but we're talking about genetic selection for energy efficiency, not protein efficiency. And the challenge is that protein is generally overfed, and it's hard to measure efficiency on something that's not limiting. Okay. If you push the level of protein down far enough, we could probably measure protein efficiency reasonably well, but we'd also lose some milk in the process. So one of the challenges of publishing this trait of residual feed intake, the nice part is it's independent of milk yield and body size, but it's hard to interpret. And we had a discussion meeting several years ago now in Chicago with a bunch of nutritionists, especially from the feed industry, and we just kept coming back to, well, milk production will go down. You want less milk production because you want less feed intake, or you want small cows. It's independent of those, right? We've already accounted for how much energy the cow needs to produce milk and for body size, but it is hard to interpret. The other part, the big challenge on the genetic side, is the reliabilities are quite low because we don't have a population of tens of millions of cows like we have for milk production, or millions of cows like we have for type traits. We have a population of thousands of, a few thousands of cows that we're using as the basis for this trait. Some countries, like in Europe, the Netherlands publishes dry matter intake as a trait. That's easier to interpret. So we have differences genetically in dry matter intake. The problem is that most of those differences are due to milk production and body size. Guess what? We already measure those traits. So why do we need another measure of those? So the approach we went with, and I'll show some details in a second here, was called Feed Saved. And this is what was used in Australia by Jenny Price and her colleagues. And it's really kind of a nice concept. So what you do is combine residual feed intake with a body size penalty. So you capture energy wasted due to being biologically inefficient, or in other words, reward those who are biologically efficient, but you also then capture the energy that you waste for excess body size. The body size part tends to be more accurate, so the reliabilities of the feed saved are higher than they are for residual feed intake. We do have to spend some time explaining this, but really what you're talking about is how much does the cow eat more than she needs to be producing milk compared to her herd mates. Also, is she bigger than she needs to be? And we do account for the rearing and salvage value and those sorts of things, and rearing costs. I'll show an example here in Australia. So what Jenny and her colleagues did was, and they introduced breeding values for feed efficiency several years ago. They were a bit ahead of us. They found that the genetic variation was equivalent to about 1% of feed consumed. That's the standard deviation of that. It seems small, but if you multiply that times the national population, it's actually a very big number. Their genetic trends in the 80s or in the 1990s, 80s and 90s, were kind of flat for these traits, bounce around a little bit from year to year. But then in recent years, maintenance costs had been going up. Residual feed intake had been going up a little bit as well. So feed saved was getting worse. And so they wanted to stop this trend and start breeding for more efficient cows. The breeding values on an annual basis, you're talking about a difference of 500 kilos between the best and worst bulls. That's a lot of feed. Now, of course, you don't pick the best or worst usually, but because we select for other traits too. But there's a lot of variation between animals, and we could use that for genetic selection. So what's happening here in the US? The next slides are a little wordy. I apologize about that. What CDCB is doing and has done in December, we got the first genetic predictions for feed saved, which is, again, residual feed intake plus the body size penalty. Body size, we've been selecting against that in net merit for quite a long time, actually, to account for the excess maintenance costs. We haven't been penalizing them as much as we should because the big cows, because the NRC nutrition requirements were not up to date. But we do include rearing, lactating, dry periods in these calculations. The body size penalty is actually based on body weight composite predicted from type traits. And so we know 1 unit of body weight composite is about 35 pounds of body weight. As I mentioned, the new NRC puts a higher penalty on those, and the body weight predictions are fairly accurate. Even for young calves that have been genetically tested, we can get reliability more than 70%. So the body size piece is one. The other piece is residual feed intake, which became a new trait in December. It's based on 9 herds. UW-Madison is the main contributor to this. I think the next biggest contributors, well, about equally, would be Iowa State and Florida. Michigan State has contributed for a long time, but they have a smaller herd, so they would be the 4th big contributor. About 655,000 daily intakes that we've collected, excuse me, from 6,000 lactations of 5,000 cows to date. The reliability of the residual feed intake is not very good. It's about 15%. It's going up a little bit this time because of some Canadian data that we brought in and added, but it's not very high. We need to keep measuring more animals. And then it's also, again, remember that it's not correlated with milk yield or body size. If you combine these two together, there's a scaling that's happening. That's where the 138 value comes in. But you combine body weight and RFI into feed saved. The units are pounds per lactation, and the standard deviation of the PTAs for cows and bulls are about 110 pounds. And so the range per lactation is huge, right? 700 below average to 600 above average. Reliability is about 30% for young calves, of feed saved about 40% for older animals. And so what we're trying to do is create medium-sized animals or modestly sized animals that produce milk really efficiently. Why this crazy looking slide next? It's to remind me to talk about where we're going forward. We're going to continue measuring feed intake, and I'll talk about that on the next slide. We're doing it, other universities are doing it, but there's a limit to how many animals we can measure on individual intakes. We're trying to look at every possible proxy we can think of, okay? And this ranges from measuring rumination, measuring feeding behavior, activity, using 3D cameras. There's research on estimates on watching the feed pile as the cow's consuming it, and trying to use artificial intelligence algorithms coupled with digital or 3D cameras to measure feed intake that way. We're looking at temperature differences. How much we've got some new data on how the temperature, body temperature, using CEDARs, mount a temperature meter on a CEDAR, how that heat increment happens after the cow eats. Do some cows change in heat as after they eat and as they metabolize that feed, or do and digest it, and does that change more than others? Infrared milk spectrum can be something we can use to look at body tissue gain and loss. Body weights, of course, so all of these different sensors. And so what we're trying to do is take all the animals we're measuring for feed efficiency directly, combine it with a bunch of indirect measures of behavior, physiology, and nutrition, and come up with something that we can measure more broadly on thousands or tens of thousands of animals. So the future kind of looks like this. Feed save PTAs were published or generated the first time in December. They'll be added to the TPI index coming up very soon. And soon after that, hopefully to net merit. They are going to be added this time, but hopefully in August or shortly thereafter. We've got about 650 cows from Canada that got added this time. That will help. So you take those now well over 5,000 cows this next time around that we've generated, add some more cows from Canada, that will help. We're measuring about 750 new cows a year, 320 of those at Madison, and then the other 430 at other universities. Developing all kinds of proxies or indirect ways to measure intake and efficiency using sensors, cameras, and so on. And then even looking at some, we're trying to understand, if you think of that pie chart I showed earlier, what's actually going on in these animals, the physiology, the immunology. Is there an energy component that we need there to maintain healthy animals? We don't want to select against something that we need. And also the rumen microbiology, what's happening in there in terms of the microorganisms, and how is it different in efficient animals from other. We got a bunch of data that will be coming out on that. And then lastly, I think it's important, what happens when the diet changes? Are the same animals efficient? on one diet as another, and the evidence suggests that generally that's true, at least within the normal range of diets, but something that we need to keep working on. So I'll stop there. I actually have one more slide I threw in just for a discussion starter or reminder, if nothing else. It's strictly anecdotal, but it's one that Lloyd Holterman shared with me on the relationship in their herd, one herd, anecdotal evidence on health costs and efficiency. And he's big on selecting and managing for improved health, if you know them. So they've reduced their health cost over a decade by, from $1 to about 31 cents a hundredweight. Feed efficiency at the same time has gone up. Now, is that cause and effect? No, a lot of other things have changed on the farm too, but pretty significant savings there because of healthier cows and more efficient cows. And the reminder or the point is that it's a win-win. Healthy cows are more efficient. So, and again, it's win-win-win because they're more efficient economically, but then it's also, there's a positive environmental impact as well. So I think I'll stop there. USDA, FFAR, CDCB funded the vast majority of this research. So I'll stop there, Amanda, and I don't know if you want to do questions or if you want to go or how you want to handle it, but I'll turn it back to you.
Yes, thank you. Thank you, Dr. Wayno. If anybody has any questions, we can definitely take those now. There's not too many of us, so go ahead and unmute yourself or throw it in the chat function, and we'll give people just a minute to see if they have any questions.
Yeah, go ahead.
I was gonna say, how long do you think it's going to take to kind of increase those reliability scores?
Oh boy, a long time.
Okay.
Yeah, I mean, if we do it the way, if we do it simply by measuring more animals, it's going to take a long time and cost a lot of money. That's probably the best way to say it. So the 4 farms that I talked about there, or 4 universities, Wisconsin, Iowa State, Michigan State, and Florida, we can do 750 cows a year, something like that. You know, if we think about really having pretty accurate data, especially for the residual feed intake part, we're talking, 20, 30,000 cows. We're at maybe 6,000 now. So you can do the math and it's going to be a long time, right? Now we could potentially get others as technologies improve. You could imagine at least some commercial farms or pseudo commercial, like a Pond Hill down in Fort Atkinson area, that could add some more cows, but it's not cheap to do that either, right? So that's one thing. One of the other things we're doing is trying to, and this gets a little bit to Matt's question here, the diversity of the bulls in our herd. Actually, what we're trying to do is make that relationship between the reference population animals in the university herd and the bulls at the breeding companies that are going to be used heavily on the farms as close as possible, right? Because the less those two groups are related, the less accurate the predictions will be. So we've really ramped up the use of the best possible bulls. They were pretty good before, but we've accelerated that pretty dramatically. And then we're getting even some heifers. We got heifers from Gen X, which is now part of Urus. We're probably going to get some from ABS that are from their nucleus program that aren't quite good enough to be IVF donors. They're that next group, and bring those directly into our herd and into our project to try to get data on the most current animals and from the most elite families in the breed. Yeah. But Amanda, back to your question. This is why we're looking at these other things, the sensors and digital cameras and 3D cameras and all of these different technologies to try and figure out, is there a way that we can take actual feed intake data on, say, 10,000 animals and combine it with predicted data from sensors on another 100,000 animals, something like that, and maybe get there that way. And then sharing with other countries. We like the Canadians, that's great. We especially like their feed efficiency data. They've been measuring a bunch of cows, and that's an easy share. There are other cases, it's a little bit more difficult if you talk about sharing data with like Australia or New Zealand, where it's a different management system. It's not quite so relevant. But certainly with the other countries that have similar management and nutrition, that's a good way to go too. Um,
We
another
have
question,
another.
how much? Oh, go ahead.
I was just going to
Uh,
read it for you, but how much will this affect TPI and net merit values in the current pools for feed save traits that are included?
This is a big question that we're all struggling with, right? And so the initial proposal, and I guess to be like completely open, um, it was supposed to go into net merit in April, and the CDCB board said, let's hold off, at least for right now. I think that's the plan at the latest one, because we're worried about how much emphasis. Because if you just follow the economics of the trait, you're putting it in about 20% weight of, or a little more than that even, in net merit. It's going to get a smaller weight in TPI. That one is more sort of subjective, the way that index is developed, but that's a lot of weight to put on a brand new trait that has low reliability, and that's the concern. So, but it has real value. Feed is expensive, so that's the big conundrum that we're in. Is the economic value is really high, the reliability is really low, and if we ignore it, we'll keep not making progress. If we put too much emphasis on it, there's a worry about making mistakes. So we'll see. I think that net merit has been one that we've tried to follow the science as best we could, and not be subjective about what the weight economic values are, but really to use the latest prices and all of that sort of thing. But it's a big number. It's 20-25% of the index if we do that. So that's something that'll have to be hammered out here in the next few months.
A little bit of a
I
balancing
guess I would,
act.
yeah, and I guess I would add, it's not the worst thing in the world, to have a trait available for a while first, have people get used to it before it goes in the index. Sure, as a geneticist, I'm supposed to tell you, use an index, all the traits should go in there, blah, blah, blah. But, having it around for 6 months or a year to understand it, get used to it, see how it compares with other traits, see what families are going to benefit or not, isn't the worst thing in the world either, right? So I'm not too upset about the whole deal.
All right. I think if anybody has any more questions, feel free to put them in the chat, but we will head on to the next portion of our program today.
Yeah, we can always come back, later or something if you think of something.
Yeah. So in the next section of our program today, we wanted to take a look at dairy and beef crossbreeding programs in Wisconsin and across the U.S. We hope that this panel discussion can help your farm answer the questions of how much beef semen you should use in your herd, what breeds are being used in the U.S., and what traits you should be looking for in your beef breeds, and if this fits with some of those breeds being used. And then finally, how do you choose what cows to breed? So first, let's start with Heather Slesher, the dairy educator for Marathon County. Heather, can you talk with us about determining how much beef semen we should use in our herds?
Sure. Thanks, Amanda. So I think I'm going to give you the typical extension answer, non-answer here, because it really is herd specific, right? How much beef semen you're using on your herd is sort of dependent on your herd. I've heard of farms that say we're going to use the bottom third or the bottom fourth, and they determine that bottom based on either they're doing genomics or they pick some genetic value, and they're selecting those bottom animals to breed to it. Yesterday, I was on a phone call with a farmer here in Marathon County, and he said, you know what? I can buy my heifers with better genetics and, that are raised up better for cheaper than I can raise them. So I'm going to sell all my heifers and I'm going to quit. I'm going to basically quit breeding to Holstein semen, and I'm going to only breed to beef, and I'm going to start raising up to beef. So what you do on your farm is really dependent on what works for your situation. But there are some tools out there that can help us. So Dr. Victor Cabrera and his group have developed this decision-making tool, or this support tool, that can help you identify how many replacement animals you need. So that way you can make sure you're not breeding too many animals to beef and not breeding enough to your dairy genetics to get those dairy animal replacements that you need on your farm. So this tool is available at the website that I have listed there for you. And it's really easy. You can either download it as an Excel spreadsheet or you can use it right there as a web-based application. The first step is to put in your herd metrics. So the number of adult cows you have, the turnover ratio, you put in all that stuff. And the very last column there or row, it calculates for you the female calves required monthly. So what is your replacement animal number that you need? So all the numbers in yellow are ones that you can put in and that you can change. Okay, the next step then is you're going to put in your criteria to implement the program. So in this spreadsheet or in this program, it's assuming you're either breeding to conventional semen, which is listed as C, sex semen, which is listed as S, and beef semen, of course, is listed as B. So again, you put in your percentages that you want to breed. You can decide what you're going to breed your heifers to, what you're going to breed your first lactation, second lactation, or second lactation greater heifers to. And then it will calculate for you how many animals you're producing of male and female. And the way this spreadsheet is working here, you can see you have two C's all the way on the top. So the first C is a male and the second C is a female for conventional. And the next two S's are male and female that you get by sex semen. And then your beef animals are all the way on the right. So by doing this, if we look at these numbers right here that I've highlighted in the boxes, this tells me how many calves I get based on conventional semen and how many calves I get based on sex semen. So every month I'm getting 44 females. Well, I didn't need that many on my farm. So I have 6 additional replacement animals. So I can tell based on the metrics that I put in this example, I have enough replacements. So you can go back through with this tool, you can play with the numbers, you can change the percentages, and you can identify how many specific animals you can breed to beef and still have enough replacement animals. So Amanda, I hope that helps.
Yes, thank you, Heather. The next part we wanted to talk about is what the current trends are in using beef semen in Wisconsin and across the U.S. Dr. Wayno, can you help us with that?
Sure. Did you want to pull? Do you have that up, or do you want me to?
I
If
don't.
not, I can find. Okay, let me just grab it here. Here we go. Back to share screen. So I just pulled a few slides here together. One of the things that I do and have done for close to 20 years now, which kind of started as a favor and seems to be continuing, is analyze the Western bull fertility, the bull fertility of bulls, mostly in the Western part, that are herds that participate in milk recording through agritech analytics, and the reasons for it I'm not going to explain, but the point being is these are maybe a quarter of the cows in the country, something like that. Tends to be California and the West, but there are about 25 states. Yeah, 534 herds in 25 states tend to be large herds, which allows a little more precise ways to analyze the data. But the point being here, we've got this is the data from the last 3 years, and I just looked at total inseminations in that data set. This is all on lactating cows, so no yearling heifers, and of those, so 2.5 million Holstein matings. About the next highest actually was Angus, about 775,000. Jersey's about 570. Simmental and Limousine. So, and there are some other breeds that I don't even mention here in crossbreds and stuff. But the point here is really to look at the relative values. So, there's more beef semen if you put those beef breeds together, about twice as much beef semen as Jersey semen that's being used for one. But among the beef breeds is really the more interesting thing. So Angus getting the vast majority of the beef on dairy mating, Simmental coming in second, and Limousine pretty distant third. Okay, I looked at a couple other things and honestly didn't find as big a trends as you might think. I tried to look by service number. One of the things you'll see is if you look at it closely, there's a little bit of a tendency for more beef matings in later services, but not as strong as I was expecting it to be. Okay, so if you can see the trend in Holstein and Jerseys decrease pretty rapidly as you go. It kind of halves from first service to second, halves again from second to third and third to fourth, whereas it stays more steady for the beef breeds, but it's not that much of a difference. So it tends to be more that people are just marking the cows for beef and they get it right from first service onward. And then lastly, I looked at it by lactation number. And you see, again, it's not sort of real obvious just looking at the data, but if you look at it sort of closely, you tend a little bit more bias toward older cows getting beef semen than younger cows, but not that much. If we had yearling heifer data in here, you'd pick up more. So I was just going to share those 3 slides, and really of the 3, the only one that's sort of interesting, I think, is the first one. Heather gave you a tool that you can use for your specific circumstances, I think, and she can comment on this, or Matt. If you look at the research that's published out there, and there's not a ton of it, but it would sort of suggest the optimum strategy. Top third of your cows and top 2/3 of your heifers get sex semen, then bottom 2/3 of cows, bottom 1/3 of the heifers get beef semen, and no need for conventional really, because the only purpose of that is to create bull or heifer cows by accident. So that's kind of a rule of thumb. But again, it depends heavily on your turnover rate, but especially on your reproductive rate. So obviously, the more efficient your reproduction, the more aggressive you can be. But it takes kind of a surprisingly small proportion of dairy on dairy matings to generate the replacement animals you need when you're using sex semen. So I'll stop there, Amanda.
All right, thank you. So one thing that our current beef marketplace has seen is a lack of uniformity in these dairy and beef cross animals. Ryan is the agriculture educator in St. Croix County. Can you talk to us about what traits we can look for in these beef bulls so that we can produce a high quality beef type animal?
Yep, I'll get the screen switched over here quick. All right, thanks, Amanda. So I will try not to carry on too long and just speak in a few generalities about some of the things we know, and there's still a lot of things that we don't know. But just starting out with how we can look at our modern Holstein steers. This is something Dr. Dan Schaefer helped our group out with before he retired from the department there. But trying to get past maybe some of the misconceptions of what the old-fashioned Holstein steers were. So as people look at using beef sires to improve them, we can't lose sight of what they're good at too. So strengths of the Holstein steer, they do have comparable quality grades, taste and tenderness, and less external fat when compared to our common beef breeds. And they are remarkably consistent in performance as a breed when we think about they haven't been selected for carcass performance as a breed. And that just speaks, I think, a lot to the many common and family genetic lines out there today in the Holstein breed, that there's enough similarity there. So some of the concerns, lower dressing percentage compared to our beef breeds, smaller ribeye size, and the shape that goes along with it. That it's kind of elongated. Some people notice it more than others, but it is something. The shape does look a little different compared to some beef breed ribeyes, especially when they're sitting right next to each other in the grocery store. That's where it sticks out a little bit more. And then this risk of exceeding packer height or weight restrictions if they're not properly managed. Again, this one is, I would say it depends. Sometimes we run into that, sometimes we don't, but it's getting away from leaving them on a high forage, high corn silage diet too long before they get on to that finishing diet where we get the excessive frames and excessive weights become more of a risk. Now, when we started out talking more about beef on dairy, one of the bullet points that's come on and off and back on and off this list is what are the buyers looking for? So a few years ago, one of the major Holstein buyers dropped out of the Holstein market, really shook that market up. Now we're starting to hear more things that it's a little more regional. In some regions, that's still the case. In others, there are buyers that do want Holstein steers. And that's just something to watch out for as this continues to evolve is that may be an issue in your area. It may not be. And we do hear things that in some areas, dairy beef steers are more accepted than others where some buyers have been told, don't buy the crossbreds. Others might be very willing to buy the crossbreds. We're starting to have to learn our local markets a little bit more than when this first became the hot topic. There we go. So just a couple things to look for as you're evaluating beef sires. So looking at their genetic evaluations, the language is a lot more EPD in terms of their genetic reports and evaluations. So we want to look at what's the ribeye EPD to increase the size and improve that shape. There's not exactly a muscling EPD, but this ribeye EPD is a great indicator of muscling in the round. So we also use the ribeye EPD as a point of emphasis to tackle both those bullet points. We want to maintain our marbling quality components. Dairy breed steers might be better than what people would assume in terms of marbling. So we want to protect that trait. But it might not necessarily be the first trait that we have to look at in improving compared to muscling. And then just not going too far one extreme or the other on external fat. Couple other things, frame size. This is going to vary depending on if we're breeding Holsteins or Jerseys. Holsteins, we want to protect that frame score, not be too large, try to moderate that frame. On Jerseys, we're going to focus more on increasing that final carcass weight, that final weight as those steers go to market. If we can, we really should think about beef offers many bulls that are homozygous polled, so we don't have to deal with the disbudding task out there. And so let's take advantage of that as we can. And don't overthink it, but start with some of the beef indexes. There's several terminal sire indexes out there that we can start with, just like you might say on the dairy side. We'll start, if your first start might be sort the bulls on net merit. This is the beef version of doing that. And then some of the breeds are getting more into having their own beef and dairy index. Angus has that dairy dollar value. Wholesome doesn't necessarily have an index, but it's a program the Simmental Association is working with the Holstein on to sort their bulls out that they think are best for use on dairy. So a little bit more on selection. Multiple breeds are going to offer homozygous black and polled sires to pick from. There's the hybrids out there, the Sim Angus, Slim Flex, to also really strongly consider. But just keep in mind, and I don't know where this falls into Kent's data, are these falling in within the numbers showing up in Angus? Are they falling within the numbers showing up in Simmental? Is there something we see more in beef where you do have these composite breeds out there where you may not see that as much in the dairy world? Just an awareness thing. Most beef breeds are going to have sires that have good potential for improving Holstein steers, but there are sires out there that they're going to fail to improve. And so that's where, instead of focusing solely on which breed to pick, do some within breed sire selection. It's kind of, and I'm going to butcher this, but so, one of those saying, if you breed an average cow to an average sire, you can't expect to get an exceptional calf out of that every time. You use average and average, you're probably going to end up with average again. And so that's where really think about this within breed selection if you can. And then just, I'd say look to the future within UW here, we have a couple different projects that we're trying to get started in this time of COVID, looking both at dairy beef cross calves, as well as can we track some of those out in their feedlot performance and carcass characteristics as well. One of those projects we're working with Dr. Jess Sindler and Dr. Matt Akins on campus there. So we're getting started. It's going to take a little while to get data, but just be aware we are looking more into this, and we'll try and get those results out to you as soon as they can. Also, industry obviously is going to be doing this research as well. We've talked to packing companies that are doing some of this. Other universities are getting animals on trial. So hopefully within the next year or two, we get a little bit more research-based information we can be sharing with you regarding this. So with that, we do have a couple resources that we cited in terms of surveying farmers and some of the considerations for breeding beef on dairy cattle. And this is along with our dairy counterparts on the Zoom today. We have our livestock counterparts as well in extension that are interested in this. So with that, I will stop sharing.
Thank you, Ryan. So those first three questions we kind of ask our panelists were more on the bull side of the equation. So next we're going to go to Matt Lipper, and Matt is the dairy and livestock or dairy and agriculture agents in Wood and Clark County. Matt, can you discuss with us a little bit on that, on choosing what cows we should be using with beef semen or dairy semen in our herds?
Sure. Thank you. So, you know, I think a number of these items have been touched on by a number of the previous speakers, but just to set the stage a little bit, I wanted to discuss what kind of genetic trend we have in our dairy cattle breeds. And I would say that not everybody thinks this way all the time, but in general, we have a pretty successful AI genomic program. We're doing some pretty intense selection, and we have a pretty strong trend. And this slide here, I'm showing the example of a net merit. The black line this is a screenshot from Enlight, which is a program with Zoetis and the Holstein Association. So there's the blue line is a herd. You'll see that'll be a little more variable, but when you get that larger population, it's pretty much entrenched that we're going to make a lot of progress by birth year every year. So if we don't know anything else about our animals at all, we should be selecting younger females to make our future herd. Sometimes I hear people question this. Maybe they don't like net merit. Maybe they select for their own criteria on their farm. But I would say that if that were the case, you'd still normally like your younger females based on your selection program than your older ones, because you're selecting them on what you want. And I think this pertains whether you use jumper bulls, if you use economy semen, if you're really aggressively selecting, you're going to be on this trend because the whole industry is on that trend. So it's just a thing. I just want to make sure that everyone realizes that that's where we're at. Conflicting with that, we want to maintain older females for maximizing our economic return on our farm, because we know that older cows milk more. So we usually say that extremely young heifers calving in at a year and 9 months or so may be only 80% of their mature potential. Second lactation even is usually not full steam of what older cow will be, maybe 90% of their mature capacity. We tend to like those second lactation animals. They know how to use the parlor. They're comfortable in the freestall barn. They're usually cleaner as far as somatic cell count, but also producing more milk. but they're still not as productive as some of those older cows. So this chart, I've overlaid my attempt at artistry. On top of that first slide is the exact same slide with genetic trend. And it's kind of economic value, phenotypic value, production, whatever concept you want to put in it. Your 5, 6, 7-year-old cows, depending on how functionally sound that cow is, could be even a 9 or 10-year-old cow, are going to be able to produce more milk if they're healthy. And because of genetic trend, they're probably also the best group of older cows that we've ever had. So if we're working with those cows daily, we can fall in love with them and say, I want more cows like that. I don't believe in, don't have the confidence in my younger heifers. And so sometimes we want to make sure these older cows have calves, but the underlying fact is that your heifers are already out of those good old cows, your younger cows. And so if you did good bull mating, they should on average be better. So I think we have this dilemma as a producer that we're trying to maintain more older cows, and there's good sound economic reasons to do that. We may like those cows, most of all of our cows in the herd, but we might still be choosing to breed them to beef semen because we believe whatever report is telling us that, and we'll get to what those reports might be a little bit later, that they're not the genetic superstars that some of our younger animals are. So what I'm showing here is that there's very little economic value. They're actually a drain on the system under a year until they calve, and then they rapidly become more profitable. They peak, and in general, these older cows, very old cows, get harder to manage and a little less productive, but that can be a pretty slow decline. And so there's still a lot of value often to keeping these cows around longer. I read the agricultural press quite a bit. And just recently, there have been a number of articles about very progressive farmers who are breeding 80% to beef. Some of them are keeping them and raising them in their own farm, but they're only keeping 20% of their calves for dairy. And so that kind of puts you in, assuming you have some culling before calving, some mortality, that kind of puts you in a 15 to 20% herd culling rate, and that's pretty low rate. But what that does for you, if you can do that, is you maximize those, you just get older cows. You maximize that high producing range and you minimize that younger range. But again, that may be in conflict with your maximum total genetic progress, but some of these newer technologies, we can maximize genetic progress and still keep these cows around longer. So for example, we could use 100% sex semen, assume we have 90% heifer crop, and we could have a heifer herd today that's, we never used to think about we could do that, but we could have a heifer crop that's nearly twice as big as our herd. Or we could do what we're all familiar with in the past, where we use just straight conventional semen. And that would result, depending on our success with rearing calves and our cows, we could have a few more heifers than we need or not. We might even in that system still find ourselves needing to purchase surplus animals. And then back to the scenario that I mentioned earlier, if you bred 80% beef, 20% sex, just think how small, how much little feed, how little facilities, how little economic drain that is on your farm to maintain that replacement herd that's only 40% of the size of your milking herd. And I think if you got a big wall of heifers out in your barn, and you aren't very satisfied with what you can sell them for, you freshen them and you just automatically increase your culling rate to whatever those number of heifers are. And if you have this smaller group of heifers, that temptation doesn't happen to you, and you keep cows longer, you maximize profitability from having more mature cows. And I think we're going to see more and more people become more comfortable with, oh, if I have fewer heifers, I can maybe raise them a little more carefully and do a little better job with them. And they're going to be a little more reliable coming into my herd. So, but, and this is what my topic is really supposed to be, you probably better be really, really good at figuring out who should be the future mothers of your herd if only 20% of your herd is going to be contributing to that. It's probably not as critical if you're not that aggressive. You don't have to get it right every time. But if you're really, really tightening down that selection criteria for the animals bred back to dairy, you better get it right. You better have a good criteria on which cows you're selecting to be the future mothers of your herd. So part of the reason that we're in this situation now is that we've had improved fertility programs, and so we're culling fewer cows due to reproductive failure. We have better cow comfort, and so we're seeing cows not get lame as quickly. You know, some of these things are critical for older cows. We know that we have less mastitis. Nationally, the somatic cell count has been dropping. And is that our environment, or is that also a result of our selection strategy that we've been breeding for lower somatic cell count and mastitis? Or is it that we've been selecting for more health traits and the cows are healthier? For whatever reason, the situation many of our herds find themselves in today is not where we used to be. And so this is a topic that's relatively new. Maybe it's because we're having a better job of keeping calves healthy that more of every birth actually makes it to the milking string eventually. So, you know, I think I made some good points, but people that like their cows are going to go, my old cows that are my very best cows maybe were born 8 years ago, and they are probably genetically superior to the average of that birth year. And so I don't care about genetic trend. I know that this cow is a really good cow, and so I'm going to keep that cow. And the other argument with that, well, I have known performance. This cow has survived that long. She's produced this well. She's got sound type. And it seems a little more speculative to go with those heifers. To help you around that hurdle, just remember that some of your heifers are out of your favorite bull selections, out of those cows that you admire so much. And so they should be better than those old cows, at least some of those heifers. That probably gets harder if you have a heifer that mama isn't around anymore and you don't like how she left the herd or whatever. It probably is a little less confident for you to go with some of those. And so what tools can help you get around that phenotypic genetic trend gap and help you make those selections? Well, the one real obvious one is genomic testing. You know, and we just got through 5 years of very, very low margins of the dairy industry. And let's say it's $40, or maybe you can get a little less than that, but it's a pretty big price if you were going to genomic test all these animals. But I just wanted to put up some numbers. You know, we usually talk about the US dairy herd being about 9 million cows. And I think Kent said we've been doing genomics for about a dozen years. And so these numbers don't entirely jive because many of the genomic tested animals would be dead and gone by now. And also I think some of these numbers involve other national herds besides the US. But I just saw a statistic that in Holsteins, there have been 3.4 million tests done in the breed so far on females, I believe that was. And I saw another statistic taking your jerseys in consideration. 5 million dairy cattle have been tested. So it's a lot of people, and this is females. So if you're testing 5 million dairy cows, this is not just to identify the future bull mothers. This is also to identify your lowest end of the herd, or it's a commercial application. So I really strongly advise, especially if you think, yeah, I'm going to breed 80% beef now, that you can justify, you know, maybe you don't have to genomically test every young female. Maybe some of them you know are lower end already, but you could probably justify with that savings of how many fewer females you're going to have, you could justify some genomic testing there. Short of that, if you don't have that, most DHI programs are combined with identification programs. So you've got the sire ID, maybe the grandsire ID, and they will give you, combined with that cow performance, some measure of genetic merit beyond just what the production of the cow is. And also your AI service can do that, your breed association can do that, and even your herd management software can do that. So I'm just encouraging you to keep those old cows, but look beyond them. And certainly the dam of some of the very best bulls of our breed lived to be 10-year-old cows, and they probably were of enough merit that they should have been used as continuing to make embryos and daughters through their entire life. That's not most of our cows. And actually genomic testing and some of these things can help us identify those older gems. But in general, you're going to be selecting more of your younger females than your older cows. And that's just my little clue there that I should be done. And let's look forward to spring.
Thank you, Matt. Does anybody have any questions for anybody on the panel or for Dr. Weigel? All right. Well, as we see if somebody throws anything in the chat, so go ahead, and if you do have any questions, please feel free to put them in the chat, or you can direct message myself if you don't want to put it for everybody to see.
Amanda, I can pull up, you know, while we're waiting, I can pull up our in light for our herd. If you want to share the screen, or I could share the screen. I mean, this is very similar to what Matt just showed. This is the UW herd. So, you know, over the last 5 years, the average is about, we're averaging $82 a year improvement in PTA for net merit. So, you know, last year's calves were 427, pretty similar, I think, to the herd you showed, Matt. This year's are going to be around 500, and those calves born this year that are, you know, below 400 are getting culled. You know, there aren't going to be as many of them because we've gone almost, you know, very heavily with sex semen just the last year or two. But this is just through breeding. This is not through, you know, IVF or any of that kind of stuff. This is just through using good bulls. About $80, a little over $80 a year genetic progress on a PTA basis.
Thank you. And I don't see any questions coming into the chat, so I would like to thank everybody for joining us today. And then just in closing, we will be sending out a follow-up email to this, to today's program, which will contain a evaluation questionnaire. And we ask that you please go ahead and answer those questions, that short 5 questions on that evaluation. Those questions and the answers that you provide us do help us to make changes, and it help us provide additional programming in the future. And then with that, just a reminder, we have 2 more programs left in this Badger Dairy Insight series. On next Tuesday, March 23rd at 1 o'clock will be Heifer Growth and Development. And then on March 30th, we will have Robotic Farm Management. What's the difference of managing a robotic farm, and a look at the economics and facility designs of robotic farming. So again, thank you guys for joining us today. And on behalf of today's speakers and the rest of our extension team, we thank you for attending and have a safe week.